this is a milestone for artificial intelligence or robotics because it's the first time that an AI beats the world champions in a physical sport. In fact, previous AI wins like Deep Blue against Kasparov in chess in 1996 or in AlphaGo against the world champion of Go in 2016 by DeepMind, those games were actually board games. A control algorithm represented by a neural network is better than any other classic algorithm. Now, neural networks learn to navigate drones with a lot of data, and there is not enough chance to get data in the real world because it would mean that you need to fly the drone millions of times in the real world, which is practically not possible. So what we resorted is simulation. So our neural network learns to navigate Swift in simulation. So we have a very good simulator where we can simulate the model of Swift, so the four propellers, the mass of the vehicle, and a little bit the aerodynamics of the air around the vehicle. And then we actually simulated a lot of trials, millions of trials of Swift trying to solve the drone racing problem in simulation. The algorithm that we used to train Swift in simulation is called reinforcement learning, where basically the neural network learns by itself to fly and race by trial and error. And only after a few hundred thousands of episodes of trial and errors, it actually learns to hover first, then to fly. And after a few million times of episodes, it learns actually to race at a speed competing with human pilots. That simulation is not reality. There is always a deviation between the simulation and the reality, which in research we call the simulation to reality gap. And this is due to the fact that, first of all, we are never able to perfectly describe the physics of a drone, which includes also the aerodynamics of the drone. It's very difficult to model air. When we simulate the drone, we simulate it as a rigid body. But, as you can see, there are some silicon dampers here. Why? To isolate the vibrations from the motors from the cameras, so that the images appear always still and not wavy. But these systematic errors, basically, that actually occur during flight, can disturb our estimation of the position of Swift. So that made it very, very difficult to simulate these effects. And that's why, actually, before we outperformed the human pilots, what we did is that we recorded a few additional data in the racing course, and then we used this data to improve the simulator. Then we refined the neural network in this new simulator using this data collected in the real world. And then we deployed it on Swift again, and this time Swift was able to outperform the human pilots. So basically what we're doing is simulation to reality, so to simulation and finally to reality.